Hi, I'm Don Jones, Curriculum Director with Pluralsight. Joining me today is IPv6 expert and enthusiast Ed Horley. How you doing, man? It's been a while.
It's been a while, yeah. Thanks.
So, I kind of wanted to give you a little bit of a setup, I guess, but it's also a real question. You posted not that long, it was a couple days ago, I think, on your Twitter feed. Oh, we're running out of IPv4 addresses. You've got like a countdown clock to doomsday. Yeah. So, here's the thing. Who cares, right? I mean, I know that's what everybody says. And I think there's 2 points of that. So, I mean, let's really break it down. If I'm running an enterprise network and I'm already doing NAT and everything else, I'm never going to run out of IP addresses because I've allocated myself 10 dot everything.
Right.
So, and this is the argument. This is the thing people go through in their head. If that's the case, why do I care?
Well, I think you care for a couple different reasons. Number one, probably because IPv6 is already running on your network. You probably just don't know it.
Horror.
Yeah, the horror of it all. So I think that's one of the things that has to get addressed for a lot of enterprises is how do you manage IPv6? Because it's already operationally running, you just didn't do anything to manage it.
Okay.
So that's one side of the story. Let's talk about the sort of address depletion side. So there are going to be circumstances that companies that are big enough actually run out of RFC 1918. So Comcast ran out of RFC 1918. There's a bunch of others. They're very large.
So thinking about especially like ISPs, they're probably one of the first ones who had to deal with it.
ISPs are going to have to deal with it, but there's also very large enterprises. So
that just have a lot of people.
Yeah, GE actually runs public v4 addressing because they never wanted to deal with that. So that's a different issue. But there are large enough companies that actually have structural problems with this. So if you're a big company that's growing really fast and you have a lot of merger and acquisition, you may actually have a lot of overlapping address space, and you may have the exact same address space as someone that you're acquiring. Do you want to spend all the effort readdressing, or do you want to do it once and just go to v6?
Okay.
And so there's opportunities, merger and acquisition cost opportunities, and you have to evaluate that. I have several companies that I'm working with that are growing very, very quickly, and that's the structural problem they want to solve. They want to do this once. They don't want to have to repeat and do it over and over.
That seems reasonable.
Right.
If you're going to do the effort.
Yeah, exactly, and that's the thing. And so you're going to go through the transformation anyway. You're probably going to do dual stack, but v6 is a great way to quickly get a company acquired in and not have any roadblocks in terms of being able to get them to your resources internally. So that's one way to solve the problem. The second way is let's talk about the security issue, which is you've got v6 running around anyway. Windows has had it by default on and enabled since Vista, Server 2008.
Okay.
OS 10 and Linux have had it on by preferred and on by default also for a very long time, 2005 or so. So when you actually go in and start poking around in enterprise networks and say, are you running v6? Most of them say, oh no, we have a policy that we don't run v6.
But you are.
But you are. And then they don't know which resources are using v6 and aren't using v6.
Right.
And then it's very hard to answer very fundamental questions like, are you PCI compliant? Are you actually watching all the things that you're supposed to be watching?
That's a good point.
And so when
if you've got maybe one device that's talking IPv6 and you're not watching, you just have no eyes on, you can't know if you're compliant or not.
Right. So that's the interesting next sort of thing is like, I'm fine with people who say, we're never going to run v6 and I want to run v4 only. I say, great. Put the effort in to prove to me you're running v4 only. So that's the other side. And so when you get down through the checklist of all the things that you have to do to make sure that you're not running v4, not running v6, too far on the other side. But if you're not running v6, then the logical question is if you go through all that effort and you're going through all the settings and you're going through all the Active Directory work that you have to do and you're going through all the network work and all the first hop security and you have to control that stuff anyway, the next logical question is, well, if you're going to do that much effort, why don't you just deploy IPv6?
Well, so let me ask you a question, and I truly don't know the answer. Is my iPhone running IPv6?
Yeah, your iPhone runs
so
v6,
this whole
especially if you're on Verizon.
This whole BYOD thing, where people are sailing in with their Android devices and their Windows phones and their iOS devices.
What Windows phone? Sorry.
Be nice. Even if you've taken the effort to lock down your Windows clients so they're not running it, you might have IPv6 walking in the door.
Yes, and in fact, if you're really big in the Apple ecosystem, and we're here in San Francisco, and most of the startups here in San Francisco that are working, all Apple
Macs,
shops, it's all Macs, it's all iPhones, it's all iPads, and Apple TVs even. And all of them use MDNS to do local discovery. MDNS prefers v6 by default first. So it will use that to actually do name resolution and actually then carry your protocol traffic between your iPhone or your iPad to do any screencasting or anything else.
At some point, it just becomes easier to manage the IPv6 instead of spending all your time trying to turn it off.
Yes. And at some point, you have to evaluate. It's different for every company.
Sure.
But I think there is value in understanding what you're getting, especially if you have compliance. If you have compliance, I would argue, and I've successfully argued, for a couple different companies, you can't actually answer your PCI audit the way you did last year because you were relying on it. Ooh. You actually weren't saying the right things, and your CEO signed off to say that you were actually in compliance. And you
actually go to jail.
Yeah, and you actually have v6 that's actually operationally running. You did not document. You didn't know that this protocol was being used. And you didn't do the captures that you were required to do on the same way on v4. So you have some structural things you need to fix. You either need to turn v6 off and actually be able to prove that you turned it off.
Which is going to be hard.
Which is going to be hard, and the same amount of effort as just to turn it on.
Just to manage it.
Yeah.
So second question then, what am I missing out on? What can't I do? Like, let's say I go down the path of I'm going to shut it off, I don't want it. What am I missing out on?
So you're missing out on a couple things. I think you're missing out on an opportunity to do a transformation about how you think about your network. I think this is one of the things that's lost for a lot of people in terms of the v4 to v6. v4, everything that we think about is constrained resources. I have X number of hosts in a subnet. I want to try and figure out the tiniest number of hosts that I can fit in this subnet to fulfill that need requirement of whatever I'm going to do.
Right, that's basic architecture.
Right, and then you go from there and you build up and you have this whole addressing scheme, but it's all based off of scarcity.
Right.
That's the fundamental philosophy. I got to conserve, don't want to give things away, don't want to give people things. Well, where are we going in the industry overall? We're going to cloud elastic capabilities. We're going to microservices, right? We're going to containers. These things are spin up, spin down, and as many as you want.
And every employee has 9 devices. You got your watch, you got your this, you got your everything.
Everything. So you're consuming more addresses more rapidly than we ever did at any time. And yet we're dealing with the older protocol that everything about it, from a fundamental design standpoint, was constrained.
Right, true.
And so with v6, to put it in perspective, a single subnet that we would use in v6 is a /64. So we have 128 bits. 64 would be the standard subnet that we would allocate in a VLAN.
Sure.
Right? In v4, that's a standard /24, right? 254 some odd addresses that we're going to use, 256 technically, but we lose top and bottom. And in v6, that 64 is the current IPv4 internet today squared in a single subnet.
Which I think people don't realize.
Yeah.
I mean, when they start talking about the basic address space, it was down to we have enough to give 10 addresses to every square meter of planetary surface, including the ocean floor. Like some just ridiculously large number because there are so many connected things now.
Yeah, it's hard to fathom how large the address space is. I did a quick blog post on my site that talked about containers. Because Docker is the big fast thing that's going on, and Microsoft's very on board with that. And I think one of the interesting things with containers is that at what point does v4 become the constraint where they say we can't scale anymore because the addressing is a problem? And so I did some quick math, and I said, well, let's allocate a 64 to a host. So just a single server that's running all your Docker containers, we'll allocate it a 64 to use for itself. So it's a simple routing policy, give it the /64. 10 million containers a second.
Wow.
Okay, how long would it take you to burn through 10 million containers a second?
A minute, or a while.
So for the /64, it's going to take you in excess of 65,000 years.
Wow.
So it's the math is in my favor. And I could be wrong about that. I have to check my blog post.
But it's still a big number.
Yeah, it's well north of 20, 30,000 years to burn through 10 million a second.
Address spacing aside, are there any technical features? I mean, are there just things I can't do on my network unless I'm running v6?
I wouldn't say there's anything you can't do. I mean, there's been a lot of innovation that first came out for v6 that was backported to v4. So IPsec is a good example.
Okay, yeah.
That was backported. And there are other features. Quality service wasn't originally intended for v4 and was backported in. So I think there's things that v4 has been adding on to extend the lifetime of v4 because it's been the most commonly used protocols, and there's good reasons for that. I think probably structurally the things around that you gain out of v6 is really the freedom about how you build your networks and how you allocate. I think one of the other innovations that's coming along is with the Internet of Things, with all the small devices and sensors.
Everything needs an address now.
Everything needs an address, but it also needs a self-assigning address that can actually do something useful. So the biggest problem with v4 is that you can't self-assign and actually do something useful with it. So the 169 address space doesn't have the concept.
The auto IP just doesn't work the same way.
It doesn't go to a default gateway. It doesn't go anywhere that you can do something useful. Whereas v6, you can actually auto-assign yourself a public.
So everything becomes much more plug and play.
Yes, and actually the protocols, the fundamental protocols for a lot of the next generation Internet of Things devices are actually built on 6. So they're built on IPv6, things like 6LoWPAN, integrated in, very efficient in the network stack, and it's designed for very small embedded kernel devices to be able to handle that stuff and go to sleep.
That you don't want to have to be able to log on to and have to set up for DHCP or
yeah.
configure static information.
None of that stuff. You just want it to come up and work. And I think the other interesting part about that is, let's talk about battery life. Something we would never normally talk about. But
Sure.
If you've got a sensor and you have to deal with NAT, one of the interesting problems you run into is that if you are talking to a cloud service and you're behind a NAT device, you have to continually keep yourself awake to keep that session open. So you have to wake yourself up, send a little ping packet that says, hey, I'm still alive, to keep that session open on whatever device you're talking
your firewall
across,
or whatever, yeah.
Whatever, in order to keep that two-way flow session happening so that
gets
cloud service can
problematic,
actually come back to you and say, hey, I need to tickle you to go do something for me.
Yeah, and it'll get routed in.
And it'll get routed in. In v6, we don't have to do that because I have a public addressable space. I can just go to sleep. And when you need to address me, you already have my address, it's registered in the cloud service. I can still firewall, and the firewall can still be completely stateful. But I don't have to worry about what your address is, and I can
It's not based on that scarcity of mapping ports and things like that, right?
Yeah, so you gain all that
sense.
structural advantage of large sensor networks that you can do that. You can also protect them back behind a firewall, still have that policy, but still know globally that they're unique.
How much of the resistance to IPv6 is cultural in the sense of, when I need an address in my company, I have to go to the infrastructure team and they have to open up their Excel spreadsheet, right?
Yeah.
I mean, this is how we managed IPv4, and the largest companies in the universe had an Excel spreadsheet. So how much of it is just a cultural change of letting go?
It is a big cultural change. I think it's, I think most of the IT industry still hasn't come to terms with the fact that we should all be using DNS and highly available DNS is really the way to go. And I laugh because there are a lot of shops that still managed by Excel spreadsheets. I'm shocked, and they should be using some sort of IPAM service, some sort of DDI appliance. DNS is really the way forward, and it's actually how we're making the transition from v4 to v6. So on the public side, when you're dealing with Facebook or you're dealing with Google or YouTube or any of the public services that are available, they are all doing this transition with DNS. And that's how companies should be doing it also. The end customer really shouldn't know the difference, and whether that end customer is us at home when we're consuming it or on our mobile devices, or whether that is actually an enterprise person who's working at their desk, they shouldn't have to know the difference between v4 and v6. That's not part of their job role.
It should just work.
It should just work. And the way you transition from one to the other is really utilizing DNS. We only had to do 2 new entries in DNS for v6 to be adopted. We did a quad A record, which is basically the way to map a namespace to a full IPv6 address, and then a PTR record, a new PTR zone, to handle the reversing, so you could look up an address and be able to get the A record or the name. That was it. That's all we had to do. So DNS allows us to transition through from the namespace to a new v6 address, and we may simply reply with a quad A record and an A record, and you get to decide. The host gets to decide, do I talk v4 or do I talk v6? Today, if v6 is available, it's preferred. So I'm going to talk to you via v6, and that's how we're supposed to transition from one to the other.
I know that one of the challenges I run across a lot with companies is, we've had DHCP for 4 decades, essentially. And you go to a large cloud service, a large-scale service like an Azure or an AWS, and they're using things like DHCP to support their IPv4 stack, but they're not running around individually statically addressing each host and keeping track of that. They're doing it centrally with a reservation-based system.
Right.
And you tell people that and their eyes kind of get big, because there's almost a superstitious aversion. Like if I just rely on the reservation, when a meteor hits my data center, my server won't get an address. You're like, yeah, but that's not your problem at that point, because meteor.
Right.
But there's this real aversion that's in place to just not trust automaticness in addressing. And it seems like so much of IPv6 is just asking us to trust it.
Yes, I would say that's true. I would say that's actually the structural advantage, because now when we're talking about being able to move things elastically between on-premises and to public cloud, and you are going to do a backup or DR recovery, you actually want the flexibility of the address changing.
You do.
Because if you have a different addressing in the other sequence, you want it to be able to come up and actually do the right thing.
Register with DNS.
Register
and
with
I'll
DNS.
get to it.
Exactly.
Yeah.
And so I think those are the things that are structurally changing. Unfortunately, public v6 isn't available in Azure or AWS today, except for some limited components. I think that's changing. I think they recognize it's important. I know both teams that are actually working on this up at both respective companies, and they're working very hard.
They're getting there.
Yeah, they're getting there. But I think the important thing to realize is that even for v4, that's an important concept to just sort of, you need to let go and you need to let the automation and the tooling.
Trust the systems.
Yeah, I mean, how do you do configuration management and automation if you don't have flexibility in your addressing? And I think that's that's a fundamental thing.
It's actually a limiting point for a lot of companies who have chosen to not have the degree of flexibility they want because they don't want to move past that trust boundary, that faith boundary.
Yeah, I mean, how do you do interesting stuff with config management? I mean, if you're going to adopt Chef or you're going to take DSC, for example, and actually use that as a role and deployment tool to allow you to scale very large, if everything is dependent on addressing and everything's dependent on static assignment, and you miss one someplace, how do you recover your assets? I mean, there's a lot of tracking nightmare. There was a tool that was built for this. I mean, DHCP was built for this. DNS was built for this. Yeah. So I think using the tools correctly is a big leap forward for a lot of folks to adopt.
You've worked with a lot of companies and a lot of people who've had to make this transition mentally. What were a couple of things that created a Eureka moment for them that made them go, oh, yeah, let's think about this?
So I think the biggest ones are that it's not as hard as they think it is. Okay. So once they get past the address format problem, I think that's the biggest scare point, is like
just
saying
giant hexadecimal.
Hexadecimal, craziness. And
I used to be able to subnet in my head.
Yeah, but the reality is that actually subnetting in v6 is actually easier than v4, in my opinion, because a /64 is pretty easy to remember, and that's pretty much what you're going to use for everything. Mm-hmm. So that's sort of gets away from which one is this? Is it a /29 in v4? Is it a /28? I can't remember which one is it. Did I do the right one? Do I have the right default gateway? No, you don't have to think about that. Actually, the router advertises the default gateway. You don't even have to put that in. So the routers, as long as the folks who are controlling the routers do the right thing, you never have to think about what your default gateway configuration actually is going to be. That's a big plus, in my opinion.
Yeah.
And then the same thing's true with the addressing format, /64, boom, I'm done. So it's really easy from a scripting angle, right? You automatically know what your subnet's going to be. So that's a win. So I think the only other part that's sort of a challenge for people is letting go of this constrained v4. So that's the next step. After they get done with the comfortableness of like, okay, I get it. I can do all the same things in v6 that I was used to doing in v4. It's going through the addressing plan and suddenly letting go of what I call v4 thinking. Because the v4 thinking was all that constraint. Right. And v6 thinking is thinking about, well, what sort of networks do I need? Not how many hosts do I need?
Right.
What sort of networks do I need to operate? Because that's what gives you the flexibility to do interesting things and to think about your network differently. And say, in terms of saying, I can't give you address space because even though you wanted to have that logical partition for that, I understand it. I'm going to operate in this portion of the network because I have too many constrained resources. I can't give you something there.
Right.
v6 frees us up from all of that. He's like, oh, you need a network for that? Here's a /64. You need a network for that? Here's a /64.
I got plenty.
I got plenty. The standard delegation that we give for a site, and a site could be my house, by the way. So this happens to be true because my house happens to run a /48. That's 65,536 /64 subnets, each with the internet squared, the current v4 internet squared in it. If that's not enough addressing for everything that you need, I don't know what is.
Yeah, and you don't need to enable your forks.
Yes. Well, maybe.
But you could. You have enough spaces.
Yeah, you have enough space. So Vince Cerf has his entire wine cellar, completely set up on v6. He gets all his sensor data information about how cool the temperature is, and you have tons of sensors in there. So when the pioneer of the internet is watching all his wine with v6, I think you can do this at home too. But yeah, that's the way we need to be thinking. Is no more constraint about what we're doing at home. No more constraint about what we're doing at the office. All those things where we have to worry about, how many wireless devices are we going to have on this network? How big of a subnet do I have to configure in my wireless?
Right.
Well, /64 I think will take care of us for a long time. Yeah. I think you can have as many hosts. We're going to run into way bigger structural problems before you run out of addresses.
Right, out of bandwidth first,
out of bandwidth.
Frankly.
Yeah, there's a lot of things you're going to run into.
Any statistics, any just gut feelings for how far along we kind of are as an industry? Is it 10% of people have kind of bought in and done it? Is it 20%? Is it 5?
It's different for the industries. So let's talk quickly about the content providers. So the major content providers across the world, the globe. So anyone who's providing content, so YouTube, Facebook, probably the two most important, Netflix,
sure,
right? That's number 3. I don't know who else counts. Google's website itself.
Probably,
right? Yeah. So out of those, all of them are v6 enabled. Okay. So, mass majority of actual content providers, including Akamai, Cloudflare, anyone else in the business of actually doing content redistribution, Limelight, all of those folks are v6 enabled. So if you click the button, and now actually with Cloudflare, you have to click it to say you don't want v6. But really? For a lot of them, Akamai is going to be switching theirs too, where you have to actually go in and tell it you don't want v6. Even if you're using their services, you're going to be v6 enabled from day one.
Okay.
So that's great news. And so that means all that content umbrella of what's available on the internet is available over v6. The second big market mover was actually mobile. So T-Mobile is actually fully v6. So if you go on T-Mobile, you're actually only on v6. And the reason they have so much support for Android devices is because they have a little client in there. It's a 646 XLAT. And the 646 XLAT client that runs on Android actually spoofs a little V4 stack in case an application actually needs it.
Okay.
And actually tunnels that service all the way back into their core and provides them V4 access. If it doesn't, it's all native V6.
Wow.
The iPhone has same support, so does Windows Phone. So these client sets of being able to do native V6 first,
They're there.
they're there. Verizon, I believe, is almost 70% of their mobile traffic is V6 native.
Okay.
So AT&T across their backbone, 50%. So there's some pretty big numbers in terms of what's happening in the service
that's a lot.
provider. Consumer, Comcast, globally, Comcast has V6 deployed. They have well northbound of 30% uptake of residential subscribers that are already moving over to V6. That means you're already running V6 at your home, you just didn't know it.
Which is the idea.
Yeah, that's exactly the idea. And so their content, their X1, their new X1 service that they're providing all the mobile media platform on is all built on V6. And in fact, their backend platform, their OpenStack infrastructure is actually running on V6. So everything that they're doing, and they had to do this to solve several structural problems for them internally. And so Jason Burkowski over there is a lead V6 architect and did the push and move, but they ran an RFC 1918 space. This was one of the reasons they had to actually move that way. And they needed it to expand subscriber base because they were out of V4.
It was a money-making thing.
It's a money-making thing. You can't make money if you can't give them the fundamental
up
thing
new
to get
people.
on the network, right? And so all the mobile providers, Sprint is on board too. So the laggards, like always, is the enterprise. So let's talk quickly about the enterprise. So the enterprise is in a different position. They have to wait for compliance. They have to wait for security tools to be built. They have to wait for the hardware to support everything they're going to do. And they have to understand what the impacts are going to be on their network. Yeah. So it's taking them longer to build structural plans. They have to think a little harder about it. They have to have more prescriptive guidance about what they're going to do to adopt.
And is that in part because there isn't a pain point, right? Comcast has to move or we can't sign up new subscribers.
Right.
Nothing's broken over in the enterprise, so there's not just a big pain driver.
That gets back to your original argument. Why weren't we moving this way?
Right.
And this is the reason why. The pain argument is not there necessarily. They can still get V4 addressing, or they're still running RFC in 1918, and they have plenty of space. So my next argument is if everyone at home has V6, you may get to the point where certain, and this is actually true in certain parts of the world, they only have V6 available because there is no V4 to provide them, or they have to go through a translation service that's really slow, or is going to be performance impacting. So it's going to become imperative that enterprises offer, at least at the internet edge of their service, some sort of way to get V6
can connect.
So your employees can connect.
Yeah.
And so they can get better service. And wouldn't you rather know exactly who you're talking to, one-to-one, versus having to go through someone else's translation service from V6 to V6 to V4 to be able to talk to you? Wouldn't you rather own that relationship end to end?
You bring that up and you even start talking about things like load balancing, and so much of the compromises we make in load balancing are around IPv4. I can't do affinity-based too tightly because I've got people who are sharing the same IP address because they're coming over at their home ISP. But you're right, if you just break that out, then you have a one-to-one relationship with everybody, and you can absolutely do much tighter affinity and better load balancing and better. It never occurred to me that there's so many things that are built into my head that are just tied around IPv4.
Yeah, and we've constrained, this is that constraint. V4 and what we tried to solve with it has constrained us over and over and over again.
Yeah.
And we're living in that world, and we're very comfortable in that world. It's sort of funny.
We know it really well.
We know it really well, and we've architected for a long time, and we're very good at it. So I get the value of rinse and repeat, right? Scripting, automation, rinse and repeat, right? So there's total value in that. But what I'm trying to do is get people to think about the bigger picture and how do you break the mindset about what's going on there. And the new opportunities that open up out of that is part of what we're sort of discussing here, which is
you
new
think about
architectures.
all these different things that we've had to say, well, I have to do it this way because, and it's usually because that's how at the end of the stack, it's because that's how V4 worked.
Right, and fraud detection. Knowing things uniquely. There's all sorts of opportunities about doing better, unique person-to-person tracking. Now, granted, we have cookies and other methodology that we use today, even behind map translation to make yourself unique, but wouldn't it be useful
That's
to be able to...
That's just kind of a workaround on top of a workaround.
Right. I think it'd still be useful. Think about what we have to do for logging alone.
Right.
So we have to log at the load balancer, the firewall, and on the host, and we have to drop a cookie, and we're probably having to log that because the sessions aren't unique end-to-end because you might be sharing an IP.
Right, and there's no other way to correlate all those logs.
Right, so we have to stitch it all together. In V6, I just need to know the flow, that's it, because you're global unique at the other end. I just need to follow you the whole path through. I reduce the amount of logging I have to do. Compliance becomes easier. Don't have to stitch as much stuff. I don't have to spend my life in Splunk trying to do rebuilds.
The workarounds we've come up with around that. You're right.
Yeah, just look it up once and you're done.
Yeah, that's amazing. Well, cool. You made a convincing argument. Hopefully some of you are convinced to at least give it a second look if you haven't started a project internally. It's a good idea. Where can folks find you online if they just want to hit you up?
Online, I'm on Twitter as @ehorley.
Okay.
And then I have a blog at howfunky.com.
Okay.
So those are the two locations. Oh, besides my course on Pluralsight, of course.
Well, absolutely, and that's what's going to be the next thing. Ed just recently released a great IPv6 course, so if you just need to dive in, use your Pluralsight subscription, get a little bit more of the basics and what this thing actually does under the hood, and maybe get a feel for how it's not all that different from what you've been doing, other than removing some restrictions. Okay. So, thanks for joining us. Again, my name is Don Jones, Curriculum Director for Pluralsight.